Hello there. Welcome to a problem session. Today we have a problem from Indian IIT JEE, and we are going to solve it in a very short time. Okay, so kind of things you need to solve this problem is you need a thermo. You can watch my other thermo parts. From thermo, you need first law, which is change in internal energy is equal to made up two parts plus other things which are zero, which has to do with types of particles. So this, and what is W? So if we're talking about a process, some process A to B, maybe A to B, A to B, and what is W A to B? It's minus PD for gas. For gas is PdV, and some from VA to VB. Okay. For ideal gas, you need some information. PV equals to nRT. This is moles, and this is gas constant. And you also need CV, and which is specific heat. Is a molar specific heat at constant volume, and CP is the same thing at constant pressure, and CP is CV plus R, and gamma is the ratio of CP over CV. So this definition you need. You also need for adiabatic process, PV to the power gamma is constant on that process. So if you know all of these, this problem is very easy to do. So it's got two compartments. First thing to notice is it says that there is no heat exchange, so Q is 0. So this part is going to be non-adiabatic in this part of the gas, and this part of the gas will change in all adiabatic fashion. So it says, reading this, you will find that this thing expands. So this thing goes over there, and so let's call this part A, and this part we can call it part B. So this becomes the B, and so the VB final is 1/2 of V0, and VA final is 3/2 V0. So that's given to us. Okay. So what we're supposed to do is first is find TB over TZ, whatever the in here. TR final, of course TR initial is T0, VR initial is VR initial is V0, and TR final is what I have to find in terms of T0. Well, so it's all about the right part, right? So right part goes from T0 V0 to some TR and half V0, and this process is adiabatic. Adiabatic. So we'll just learn PV to the power gamma is constant. Is PV to the power gamma is constant. So we can write this into temperature also. So P can be, there's no P known here for us. So we can say PV equals nRT. So this nRT over V to the gamma is constant. So you can see the this thing can be sent on the other sides because it's constant. So TV to the power gamma minus 1 is constant. So this is sufficient to solve this problem. So this just means T final V final gamma minus 1 equals T initial V initial to the gamma minus 1. So that's what this will be. So just putting in there, we're supposed to get TR over TI. So this is going to be TR over TO, V initial over V final to the gamma minus 1. And this is half, so this is 2 to the power gamma minus 1. So if I know gamma, I would be done. For gamma, we have CV given, right? So gamma is CP over CV, and this CP is CV plus R over CV. So it's like a 3 over 2. So this is going to be square root of 2. And sure enough, we see that's the answer. So answer is A. So this is for question 15. Okay. Now the second one is you can see that from here it has gone here, part A, but I'm gonna I mean, you can do several different ways. This is the only source of heat, and you can see that when it's moving, when this thing is moving, there will be work done on A by B and vice versa. So I could actually, to get Q, I could just look at this part and do the Q. But I find it much easier to look at this whole thing, other than the heater, as my system. So initially, so let's look at that. This whole thing is in a system. So it's going to give me Q, and it's kind of made up of two parts, part A and part B. And at t equals 0, you have a T0, V0, and T0, V0 here. So then after this much heat has come in, this gets transformed into some T left, okay, then 3 over 2 V0, and TR we just found over here, some TR and V0 over 2. The reason I do this is when I look at this whole system, the work on this whole system. So we're going to look at the combined system. Work on the combined system going from, say, state initial to state final is 0. So the Q will just be delta U. And so this is going to be U final minus U initial. And what is the internal energy? Internal energy of this guy, internal energy of that guy. So it's going to be internal energy of the B, UF of B, A, and UF of A, B, and minus UI of A minus UI of B. So U of ideal gas is actually N times CV. Delta U will be CV delta T. And so N is 1 here, 1 mole. You can see it's given as 1 mole. So this is equals to 1. So this is equal to 2R. So this is 2R delta T for us. So this would be UF of A will be 2R final temperature, which is TL, plus this guy will be 2R and final temperature TR, and this is going to be minus 2R T0 minus 2R T0. So this was initial, this initial, and this is the final. So if I know what TL is in terms of T0, this I know in terms of T0, and so if I know TL in terms of T0, I can be actually solved. Okay, so let me get some space. Well, let me just write this down first, what I need. So this whole thing I can write down Q and over R times T0 will just be 2 is common to everybody, and you have a TL over T0 plus TR over T0 minus T0 minus 2. Okay, so this one is square root of 2. Okay, and so we need to figure out TL over T0. All right. Okay, so I'm going to find TL over T0. So I'm going to look at when you get this final system here. So you have a P final on the B side and P initial on the A side. So I'm heating slowly, so as we can see that the final, these has to be P final of these guys have to be equal to each other. So we have P A final, B A final, TA final equals to P initial, PA initial, VA initial over TA initial. That's one equation from the left side. On the right side, we have a P B final, VB final over TB final should be equal to PB initial, VB initial over TB initial. Now we know that this is equal to this, and we know that this is equal to that. Right away, if I take the ratios of all of this, we are going to get what we want. So let's take ratio on the left with the left, right with the right. So we have a VA final over TA final, and this is going to invert. TB final over VB final will be equal to VA initial over TA initial, TB initial over VB initial. So you can see that the initial, these guys all cancel out, okay? And the final volume, VA is 3 times the VB volume. So this becomes 3 half, and this is half. So that makes it 3 times. And this TBF is what TR is. It's the square root of 2 T0. So this side is 1, and so you can see bring this on the other side and T is on the other side. So TL, this is TL, this is the final one which we're calling TL, is equal to 3 times square root of 2. So this will be 3 times square root of 2. So this is 2 times 3 times square root of 2 plus square root of 2 minus 2. So 2 can come out, and becomes 4 times 2 square root of 2 minus 1. Pretty cool. So this is, answer is this. Okay, so that solves this problem. And you can see it's complicated, but there's a method to this madness. Usually thermodynamics problems go like this. You have to make use of some knowledge about the adiabatic process, some knowledge about the gamma, some knowledge about this, and PV equals to nRT, and you have to know this in separately and be able to put them back together. And there are multiple ways of solving the same problem. Okay. Okay, so that's it. Talk to you later in another video. Bye.